Measures of dispersion, defining and illustrating variability. Measures of dispersion are statistical tools that quantify the spread or variability of data points around a central value. They provide insights into how much the data deviates from the average. We will explore the range, quartile deviation, mean deviation, and standard deviation. Numerical example dataset 10, 15, 12, 18, 28, 14. 1. Range. Definition. The range is the simplest measure of dispersion, representing the difference between the maximum and minimum values in a dataset. Numerical example. Maximum values in a date. Minimum value 8. Range equals 20 minus 8 equals 12. Interpretation. The data spans a range of 12 units, indicating the total spread of the dataset. 2. Quartile deviation QD. Definition. The quartile deviation QD measures the spread of the middle 50% of the data. It is calculated as half the difference between the third quartile Q3 and the first quartile Q1. Numerical example. Sorted data 8, 10, 12, 14, 15, 18, 20. Q1 first quartile 10. Q3 third quartile 18. QD equals 18 to 10 /2 equals 4. Interpretation. The middle 50% of the data varies by 4 units around the median, indicating the spread of the central data. 3. Mean deviation MD. Definition. The mean deviation MD measures the average of the absolute differences between each data point and the mean of the dataset. Numerical example. Mean mu 10 plus 15 plus 1 2 plus 1 8 plus 2 0 plus 8 plus 14 7 equals 13.86 approximately. Absolute deviations 10 to 13.86 equals 3.86. 15 to 13.86 equals 1.14. 12 to 13.86 equals 1.86. 18 to 13.86 equals 4.14. 20 to 13.86 equals 6.14. 8 to 13.86 equals 5.86. 14 to 13.86 equals 0.14. MD equals 4.86 plus 1.14 plus 1.86 plus 4.14 plus 6.14 plus 5.86 plus 0.14. /7 equals 3.29 approximately. Interpretation. On average, data points deviate by 3.29 units from the mean, showing the average absolute deviation. 4. Standard deviation sigma. Definition. The standard deviation sigma measures the average squared deviation of each data point from the mean. It is the square root of the variance. Numerical example. Mean mu 13.86 approximately. Squared deviations 10 to 13.86 squared equals 14.89. 15 to 13.86 squared equals 1.29. 12 to 13.86 squared equals 3.46. 18 to 13.86 squared equals 17.14. 20 to 13.86 squared equals 37.70. 8 to 13.86 squared equals 34.34. 14 to 13.86 squared equals 0.02. Sigma equals square root 14.89 plus 1.29 plus 3.46 plus 17.14 plus 37.70 plus 34.34 plus 0.02 squared equals square root 15.55 equals 3.94 approximately. Interpretation. The data points have an average square deviation of 3.94 units from the mean, indicating the spread relative to the mean. Comparative analysis and interpretative framework, tabular format. Measure, definition, example, result, sensitivity to outliers, use case, interpretation, range, difference between max and min, 12. High, quick overview, simple, limited by extremes, QD, half the difference between Q3 and Q1. 4. Low, skewed data, outliers, robust, central dispersion, MD, average absolute deviation from mean, 3.29, moderate, absolute deviations, forecasting, average absolute deviation, sigma, square root of average squared deviation from mean, 3.94, moderate to high, general statistical inference, comprehensive, mathematically tractable,